We are now going to talk about H10K kinematics and review. Okay, and I'm just going to walk through my steps here. Writing all of this down would take ages. So the first question here, a particle A moves so that the velocity at time t is given with this function. Okay, v stands for velocity in this case. The kinematic energy E of the particle is measured with this formula. Write down the expression of E as a function of time. So we know that E is equal to 5 times the velocity squared. So to write this expression in terms of time, I'm going to replace v with 2 sine t, and since it's v squared, we're going to have that squared, and then 2 squared, that's going to give me 4, and then sine t squared, we rewrite it like this. So whenever you see the little 2 right here, this means sine t squared. Okay. So now let's talk about the next one. Okay, so now find the derivative. Okay, so here is my function. E equals 20 sine t squared. So I'm going to make u, I'm going to use the chain rule here. Okay, so use the chain rule. I'm going to make E equal to 20u squared, and I'm going to make u equal to sine t. So the derivative of sine t is cosine t, and the derivative of 20u squared is 40u. So dE du times du dt gives me 40u times cosine t, and then finally I replace u with sine t. All right. Hence or otherwise, find the first time at which the kinetic energy is changing at a rate of 5 joules. So what I do is I put in my equation here, and so 40 sine x cosine x. Okay, now this is the function of the rate of the derivative, right? So, and then also we want to find the first time that it intersects a rate of 5. So I'm going to also make a line that says 5, and oops. And okay, at first I see my graph looks wonky, right? So we want to find the first time that it intersects 5. So that's like right there. But I don't like this graph first. I'm going to change the window because it's cutting off. So let's change the window. I'm going to change the y min and y max. I'm just going to be crazy. 50 and negative 50 and 50. And now see what the, oops. Ugh. Let's do this again. I managed to make this positive 50. Well, it looks like 30 is probably good enough, but what on earth? Ugh. Let's try this again. Okay, now it should be fine. So we want to find where it intersects here. Okay, so second trace. Well, I guess right there is the first place, right? Okay, so intersect. So I get close to it, right? Enter second curve. It says equation 5, enter, and this intersection here is 0.1263. Okay, so these are the buttons you press. Second, trace, 5 for intersect, enter, enter, enter. Okay, this first one is for the first equation. This one is for the equation y equals 5. This enter is for the guess, and then we get that. Okay. Next question, number 2. Consider this function. Find the derivative. Okay, so the first thing I'm going to do is I'm going to make all of this equal to u. Okay. Excuse me. So I made all of that equal to u. And so I've got the square root of the blue stuff. I'm going to just write that to the 1/2 power. So I've got u to the 1/2 power, and u is equal to this stuff here. So I take the derivative of each thing. We're going to do the chain rule again. Okay, so the derivative of u to the 1/2, 1/2 comes to the front. Derivative of that is going to give me u to the negative 1/2, and du dx gives me negative 2ax, and the derivative of x gives me 1. So using the chain rule, we're going to have the derivative is equal to this stuff times this stuff, using the chain rule. Okay, and then finally, I'm going to replace u with this blue stuff here. So my numerator is going to have the negative 2ax plus 1, which you see right there. And in my denominator, I'm going to have, because this is really negative to the power of negative 1/2 is really, in my denominator, I've got the square root of the blue stuff, and then I've got 1/2 here, so I'm just going to put the 2 in the denominator. Okay. A is greater than 0 and has a local maximum. Find in terms of A the value that x is going to be to maximize this. So if we have a local maximum, that means the first derivative is going to be 0. Okay, at any maximum or minimum, the first derivative is going to be 0. Okay, so I'm going to set my numerator equal to 0. So I'm going to set the negative 2ax plus 1. I'm going to make that equal to 0. So I can I can subtract 1 on both sides, and then I can divide both sides by negative 2a, and then I get x is equal to 1 over 2a. So this value, 1 over 2a, is going to maximize, to give us a local maximum for my graph here. Okay, hence, find the value of a in which y has the smallest possible maximum value. Okay, so what we do, so we're going to substitute 1 over 2a in for x in the original function. So here's the original function, okay, and I'm going to replace a I'm going to replace x with 1 over 2a. Okay, and then I can simplify this. So I have negative a times this, which is going to give me this here, and then I have plus 1 over 2a, and then plus a. So now I need a common denominator, so I'm going to have negative 1 over 4a plus 2 over 4a plus a, and these two terms here simplifies to this here, square root of 1 over 4a plus a. Okay. From this point right here, I'm going to put this into my calculator. Let's just do that right now. Okay. Okay. Parentheses 1 divided by parentheses 4x, close parentheses, plus x, close parentheses, power negative, oh no, it's not negative, 0.5, so to the 1/2 power. Let's see, did I type that in right? Okay. So let's graph that. Oh, I didn't need that. Okay. So okay. So what did we do? So if I do second trace and I want to find this value right here, we go 3 to minimum. And so if I do the minimum, second trace minimum, I'm going to find a value of 0.5, and that's my minimum. So this has a minimum value when a is 0.5. Okay. This is probably going to be multiple parts for this video. Okay. So a spherical balloon is being inflated such that the volume increases at a rate of 15 centimeters per second. Find the radius of the balloon when the volume is 288 pi. Okay, so the very first thing I'm going to do is I'm going to get my formula packet and figure out the volume formula. Okay, and if I get my formula packet, the volume of a sphere is 4/3 pi r cubed. Okay, and I've written that down here. So they've told us the volume is 288 pi, so I've replaced the volume with that, and then I can see the pi's cancel out, and then I can multiply 3/4 on both sides to make that cancel out, and then 288 times 3 divided by 4 gives me this, and then I take the cube root. Now on your calculator, because every year I get students, so how do I do the cube root? So you just do 216 to the power of 1/3. Okay, and then that's going to give me 6. Okay, so now this next part was a little tricky. In fact, I'm going to rewrite it just so that you can see what's going on here. So, hence, otherwise, find the rate of change of the radius at this instant. So we're trying to find dr dt. Okay, so dv dr is equal to, so if, let's see, we've got the volume equals 4/3 pi r cubed, right? This has volume and radius. So if I do dv dr, this 3 comes to the front, and then I have 3 times 4/3 pi r squared, which just simplifies to dv dr equals 4 pi r squared. Okay, then the other thing is we know that d v dt, they've already told you is 15 at this point. Okay, but we're trying to find dr dt. So d v dr equals d. What did I do here? We're trying to find dv dt equals dv dr times dr dt. There we go. There we go. Okay, so I know that dv dr is this, and I know that dv dt is this. So now I can solve. So this is 15 equals 4 pi r squared times dr dt. When we were looking at this review packet answer key, this one was kind of tricky, but hopefully this helps. So, all right, so now I need to divide both sides by this yellow stuff here. So now I can say dr dt equals 15 over 4 pi r squared. Now we know r is 6, right? So this is going to be 15 over 4 times pi times 6 squared. So 6 times 6 is 36. 36 times 4 is going to give me 144. So we end up with 15 over 144 pi is the rate at this instant when r equals 6. When r equals 6, this is our rate. Okay? Next question. Okay. Okay. We want to find the tangent line to this curve at point 1 comma e squared. Find the coordinates of the point where L meets the x-axis. Okay, so in order to find a tangent, we need the first derivative. We need to find the first derivative. Okay, and this is a tangent line. They want the line that's tangent. Okay, so we're trying to find the line that's tangent. So I've got y equals x times e to the 2x. So I'm going to use product rule this time. So I'm going to make u equal x, and I'm going to make v equal e to the 2x. So the derivative of where u equals x, I'm going to have the derivative is 1. The derivative of e to the 2x is equal to 2e to the 2x. So using the chain rule, I've got u, which is the x, times v prime, which is that, plus v, which is that, times u prime, which is this. Okay? And then, so we want to do this when x equals 1, right? So when x equals 1, we're going to plug in 1 in place of x. So if I plug in 1 in place of x here, then that becomes 1, this becomes 1, and this becomes 1. Okay, so then I have 2e squared plus e squared. So add those together and I get 3e squared. So this is my slope when x equals 1. So we're still trying to find the tangent line. So here is the equation of a line in point-slope form. We just said that the slope is 3e squared, and we've got this point 1 comma e squared. So I'm going to replace y sub 1 with e squared, and I'm going to replace my x subscript 1 with 1. Okay. Then now I can do distributive property with the 3e squared, and that's what I did here. And then I'm going to add e squared on both sides, and then I get y equals 3e squared x minus 2ex. So there is my equation of the tangent line. This is the equation of the tangent line. Okay, that's my equation of the tangent line. So L meets, so we want to find the coordinates of the point where L meets the x-axis. Okay, so here's my equation of the tangent line, and we want to find out when the equation meets the x-axis. So when an equation meets the x-axis, that means y is going to be 0. Because if I've got any old equation, when I've met the x-axis, we know that the y value, 1, 2, 3, this y value is going to be 0. Okay? So, I've got this equation of the tangent line, and I'm going to make y equal to 0. Okay, so now I've got 0 equals 3e to the 2 e squared x minus 2e squared. So I can add 2e squared on both sides, and I get this. I can cancel out e squared on both sides, and then I get 2 equals 3x. And so I divide both sides by 3, and I get this. So now I've got the coordinate where this line here meets the x-axis. So my x value is 2/3, and we already know that the y value is 0. And let's just do the next two parts in a separate video.